Welcome to CrystalMaker 11. This tutorial is a worked example showing how to build a crystal shape for the mineral quartz using a set of relative plane measurements and the new lattice planes inspector that we introduced in version 11.5. If you haven't watched the separate video tutorials introducing the planes inspector and crystal shapes basics, we strongly recommend that you watch these before proceeding with this tutorial. Let's consider a crystal shape centered at the origin. If we measure the perpendicular distance of each face from the center, we begin to notice that the largest faces have the shortest distances and the smaller faces have the larger distances. In fact, it has been shown that the energy of the face is proportional to this distance. So a good way to start would be to list a set of faces with their relative energies, and we'll use these to set the distances of the planes from the center. Let's illustrate this for the mineral quartz. Quartz typically forms prismatic crystals, faces of the form 100, capped with pyramidal ends, in other words, faces of the form 101. Smaller faces parallel to 111 and 511 may also be found. We'll start by loading the crystal structure of quartz from our library, and now we can go to our planes inspector to add the lattice planes. Let's start with a set of symmetry related 100 planes, which we can add using the dialog. Critically, we'll specify add symmetry relations. This is going to do the hard work for us. Clicking the add button shows all 6 symmetry related planes. And note that they're all passing through the center of our model. We're going to change that later. Let's tidy this display by grouping the symmetry related planes by clicking the group button in the bottom bar. Now the list has been collapsed into a single row with a disclosure triangle. Notice that the row title has 100 in squiggly brackets. This is crystallographic shorthand for all planes related by symmetry. If we expand the list by clicking the row's disclosure triangle, we see our individual 100 type planes, each with rounded brackets as befits a single plane. Now, one little note we should make here is that for trigonal and hexagonal crystals, we have the option of using a 4-index notation for lattice planes, so-called Miller-Bravais indices, where there is a redundant third index, so 100 becomes 10 bar 10. I'm going to just use 3 indices now for clarity, but that's something you can turn on or off or set as a preference. Let's focus on these planes by hiding the unit cell and the atoms. So we'll start by hiding the unit cell and we'll hide the atoms. And the easiest way of doing that is to go down to the view button here and we'll hide visible atoms. Now we're going to want to move the planes to define an actual 3D shape. And we have a position slider for that, but we need to make sure that this is set to display absolute distances in angstroms and not fractions of the plane normal. This is important because some planes have longer normals than others, so absolute units in angstroms. So we can now move our planes outwards from the center by the same amount. So let's drag this out to about 2.5 angstroms. And we're interested in the inner shape defined by the planes. That's this inner shape here, which looks like a hexagon in this 2D view. And we'll emphasize that, as we've seen in earlier tutorials, by switching to shape mode. And that hides the outer sections of the planes and just shows the inner region defined by the first set of intersections. And we can see that this is a hexagonal prism bounded by the plot range. It's open at the top and the bottom, so we need to cap it with more planes. Let's add the rest of the planes from our original list. So we'll start with 511. And let's drag the position slider for that out from the center. Now we'll add 101. And we'll move that out to about 3.5 angstroms. Finally, we'll add 111. And we'll move that out to about 3.5 angstroms as well. Let's colour these planes by symmetry. Going down to the Actions menu, Colour by Symmetry. Now we had some specific numbers that define the ratios of the planes' distances from the centre that we looked at in a table at the start of this tutorial. And we can enter those values directly into these distance fields. So let's do that then. I'm going to add 1 for the 100, 1.323 for 101, 1.311 for 111, and we had 1.121 for 511. So here is our correctly proportioned quartz crystal. Let's show this with our crystal structure. We'll go back down to our View button and we'll do Show Hidden Atoms. And let's just auto scale that for the moment. Well, the shape's a bit tiny, isn't it? And we'll scale the shape to fill the available bounds with the Resize option. Scale shape to fit. And let's add more atoms by increasing the plot range. So we'll go to the Range command and let's add some more cells. Let's scale the shape again. And now we'll hide all atoms outside the shape using the Slice with Planes command. Finally, we'll make our planes translucent so we can see what's inside. Now we could do this individually by group row, but for the whole shape we can do it using the Actions menu, and we can set the opacity. Let's go for about 40% here, and let's give it a spin. So this is a translucent crystal of alpha quartz showing all atoms inside. We can change the model type while we do this. Let's have a polyhedral model. Those are our silicate tetrahedra joined together at their corners to form an interconnected three-dimensional framework, which makes quartz a very hard material. So in summary, we have shown how to create a three-dimensional crystal of quartz. We started with 4 sets of symmetry-related planes and entered their relative distances to the crystal center. We're switching to shape mode, reveal the 3D shape. We colored the faces, we set their opacity, we scaled the shape to fill the available plot bounds, and use those visible planes to slice our structure so that only internal atoms are visible. If you haven't already done so, explore the gallery of crystal shapes provided with CrystalMaker 11.5 or later.